Hi, today we're going to the 2015 PAT paper looking at question 6. So question 6 asks us that if we are given an unbiased coin and it is tossed 3 times, what is the probability that A, 2 or more of these tosses are tails, B, 2 consecutive tosses out of the 3 is the same, or C, all the tosses are tails if any one of our 3 tosses is known to be a tail. So the fact that this coin is unbiased means that the probability of tossing a head equals the probability of tossing a tail on any given toss, i.e. the probability of tossing a head and the probability of tossing a tail are both 1/2. So let's start with part A. So the way to approach this question is to list the combinations in which we get 2 or more tails, and we have any of these combinations happening to get the required result. So our first situation would be simply getting tail, tail, tail. Or we could have tail, tail, head. Or we could have head, tail, tail. All 3 of these outcomes are equally likely to happen because it's an unbiased coin. So we find the probability of 1 happening using our OR rule. We can simply add it or multiply it by 3 to get our result. Probability of getting 3 tails in a row, well, the probability of getting a tail in the first toss is 1/2, and then a tail in the second toss is 1/2, and the third toss it's also 1/2, so we get 1/8. So that means adding this up or timesing it by 3, we get the probability of 2 or more tails is 1/8 times 3, or simply 3/8. Now on to part B. So part B wants us to find the probability that 2 consecutive tosses are the same. So again, we're going to list out the combinations in which this can happen. So we have the same ones as before. We could have tail, tail, head. Or we could have head, tail, tail. But this time it's only 2 consecutive tosses of any, so it could be 2 heads. So this time we could have tail, head, head. Or head, head, tail. Now we know the probability of any of these 4 things happening is 1/8 because they're all equally likely, and we've already worked out that this one's 1/8. So any 4 of these is 1/8. So the probability of 2 consecutive tosses the same is, well, probability of 1 is 1/8. And we have 4 of them, so times it by 4 because they're all the same, and that gives us 1/2. Now finally on to part C. So part C wants us to work out the probability that all 3 tosses are tails when we know that one of the tosses was a tail. Now this is conditional probability. So what this means is we want the probability that 3 tosses are tails given one of them is a tail. So we know what our formula is for conditional probability. So this means we want the probability, and we're going to write 3 tails, 3t for 3 tails, 3 tails and 1 tail divided by the probability of 1 tail. Now think about this carefully. The probability that we have 3 tails and 1 tail is simply the probability that we have 3 tails, because if you have 3 tails you've obviously had 1. So this probability includes this one. So we can simply write this as the probability of 3 tails divided by the probability of 1 tail. Well, the probability of 3 tails we know from before is 1/8 because it's just t, t, t. And the probability of 1 tail would simply be, well, think about it. If you want 1 tail, you can't have them all being heads. So if we were to do the probability, find the probability of all of them being heads, so HHH, which is going to be the same as TTT, which we know is 1/8, then we can simply have that it's 1 minus that. So we're going to have 1 minus the probability that we have 3 heads, i.e. 1 minus 1/8. So that gives us 1/8 divided by 7/8, which gives us the final probability as 1/7.